Okay, so the first phenomenon that we are going to explain is the Doppler effect. The Doppler effect is a change in the observed frequency of a wave occurring when the source and the observer are in motion relative to each other, with the frequency increasing when the source and the observer approach each other and decreasing when they move apart. The motion of the source causes a real shift in frequency, with the motion of the observer producing only an apparent shift in frequency. That's also why the Doppler effect can sometimes be called the Doppler shift. Okay, so here we have the Doppler effect. We can compare the Doppler effect when we see a stationary car honking its horn and a moving car honking its horn. So in figure 1, we know this is a stationary car honking its horn because all of the waves are equidistant and constant. We see the Doppler effect in action when we see the object that is moving emitting waves. You can see one side, there's a higher frequency, that's the side where all of the waves are bunched up, and a lower frequency on the side where all of the waves are spread apart. The Doppler effect is shown when the waves bunch up on the direction that the object is moving in and is spread apart on the opposing side. Okay, so in terms of analysis, here we have a drawing that basically draws out everything that we saw in our video. So in the middle on a snowbank, we have Isaac, who is recording the video, and I'm in the car. So when we were making this recording, Isaac was standing in the middle of a snowbank. In the car, at the end of the street, Mahima is driving really fast and honking the horn. To Isaac, the horn might sound like it is going from an A to an F sharp, because to Isaac the sound waves go from front, middle, back. Isaac is hearing the car go from a high frequency to a low frequency, or a high pitch to a low pitch. Mahima, who is inside the car, will only hear the A. The frequency for her is constant and equidistant.
However, when an object in motion is moving faster than its resulting waves, an interesting phenomena happens. This is a sonic boom, the extreme older brother of the Doppler effect. A sonic boom is comprised of lots of waves with their amplitudes all stacked on top of each other.
So if our object is moving towards a stationary observer, the observer will perceive the wave to be at a higher frequency than it actually is. And we can also consider this to be the same fact vice versa. If the object is moving away from the stationary observer, the observer will perceive the wave to be at a lower frequency.
I think it already was purple.
I don't have purple.
Okay, so the second phenomenon that we are going to explain is the science of mixing pigments. So a pigment is a material that changes the color of reflected or transmitted light as a result of wavelength selective absorption. A pigment acts like a color filter. For example, the color green is created because the pigment absorbs all of the colors of white light besides green. So how was a new pigment created? To understand this, we need to develop an understanding of the color wheel. So that's the basic Roy G. Biv, or red, orange, yellow, green, blue, indigo, violet. So, when there's a red pigment, the red pigment will reflect mostly red, but it will also reflect a little bit of violet and orange, and that's how mixing colors is impacted. We will get to this after seeing how colors are mixed. Okay, next I'm going to basically give an analysis on color mixing by focusing on what happens when red pigment is mixed with yellow pigment. Yellow pigment will reflect mostly yellow color, and it will also reflect some orange and green because they're next to each other on the color wheel. Red pigment will reflect mostly red color, and also some orange and violet because they're next to each other on the color wheel. So what happens is, violet and green pigments get absorbed by the yellow and the red, respectively. Because orange is the color that is most common with both pigments, the orange is reflected, not absorbed. So here we have the yellow and we have the red. They're mixed together and it makes orange. That's because orange is the common reflected pigment.